when the second row of differences produces a constant number, the sequence is called a quadratic sequence. Now, for example, in this case, we are required to find the next three terms in this sequence. And it's a quadratic sequence, which means we are expecting the second row of the differences to produce a constant number. So we'll find out soon. So the first step is to find the differences. So the difference between 5 and 14 will be 9, and here it will be 13, and here it will be 17, and here it will be 21. And then, so those are the first differences. Let's look at the second differences. The second differences will be 4, 4, 4. And you can see that the second row of differences produces a constant number. And therefore, this is a quadratic sequence. Anyway, we are assuming that this pattern goes on and on and on. Of course it does. So we are going to use the same pattern to generate the next three terms of this sequence. So let's look at these differences. The first differences, they go up in fours. So if that's 21, that will be 25, and that will be 29, and that will be 33. And then we can use those to find these terms. For example, 25 plus 65 will be 90, so which means that will be 90. 90 plus 29 will be 119. 119 plus 33 will be 152. So the next three terms are 90, 119, and 152. Okay? So how do we find the position to term rule, or the nth term of a quadratic sequence? Now all quadratic sequences, all of them are written in this form. So all quadratic sequences are written in that form. So whichever nth term that you're going to look for any quadratic sequence is given in this form, where A, B, and C are constants. They're just numbers, okay? It could be a positive number, negative number, it could be a fraction, any number that's a member of real numbers. And A is not equal to 0, because if A is equal to 0, then we have a linear sequence. We won't be having a quadratic sequence. So A is not equal to 0 for you to have a quadratic sequence. Anyway, so what I'm going to do is I am going to find the first 5 terms of the general quadratic sequence. So I'm going to use this formula. So let's assume this is the nth term of general quadratic sequence. And I want to use this formula to generate the first 5 terms of that general quadratic sequence. So the first term will be given by, of course, to find the first term, I plug 1 in place of n. So that will be A into 1 squared plus B multiplied by 1 plus C. And that will give me A plus B plus C. The second term will be A into 2 squared plus B multiplied by 2 plus C, which will be 4A plus 2B plus C. The third term will be A into 3 squared plus B multiplied by 3 plus C, which will be equal to 9A plus 3B plus C. The fourth term will be A into 4 squared plus B multiplied by 4 plus C, which will be equal to 16 A plus 4B plus C. And the fifth term will be equal to A into 5 squared plus B multiplied by 5 plus C, which will be equal to 25a plus that's 25. So 25a plus 5b plus c. So what we have here, these are the first 5 terms of a general quadratic sequence. Okay, so remember we want to come with a way on how we can find the nth term of a quadratic sequence. But these are the first 5 terms of the general quadratic sequence. And what we want to do is to use these five terms of the general quadratic sequence to try and come up with a relationship that can help us to find the nth term of a quadratic sequence. So, what we have here is we have the first term, second term, third term, fourth term, and fifth term for general quadratic sequence. And what we want to do next is to find the first and the second differences for these general terms. So let's start by finding the first difference. So the first difference here will be 3a plus b, because if you subtract a plus b plus c from 4a plus 2b plus c, you'll have 3a plus b. Here it will be 5a plus b. Here we have 7a plus b. Here we have 9a plus b. And then the next row for second differences will be given by, that will just be 2a. That will be 2a as well. And 2a. Which makes sense because what we said for a quadratic sequence is that the second differences should be the same. And we have 2a in each case. So we can conclude and say that a, the second difference is always equal to 2a. The second difference is always equal to 2a, which makes sense. Yeah. Another thing that we can conclude is the second difference. I've already said that. Anyway, the next thing that we can conclude is that just by inspection, remember, this is the first term, this is the second term, third term, fourth term, and fifth term. We can see that the difference between the second term and the first term is equal to 3a plus b. So we can say that the second term so the second term minus the first term is equal to 3a plus b, what we have here. And the other thing that we can conclude, of course, this is really not a conclusion, it's just an observation, that the first term is equal to a plus b plus c. Now, we can use these 3 observations to find the nth term of any quadratic sequence.